Y-type stars are among the coldest stars in the universe. They barely glow. These stars are smaller than our sun and are also much cooler. Often referred to as failed stars or brown dwarfs, this is because they cannot sustain nuclear fusion in their cores like our sun. Y-type stars emit very little light and heat. Their surface temperatures can be as cool as the human body. Imagine a star you could get close to without burning up. That's a Y-type star. These stars are fascinating objects that challenge our understanding of star formation and evolution. If our sun were a Y-type star, our solar system would be vastly different. The habitable zone where liquid water can exist would be much closer to the star. Planets like Earth would need to orbit much closer to a Y-type star to be warm enough for liquid water. The planets would also be packed closer together. The gravitational pull of a Y-type star is weaker than our sun's. This means the planets would be less tightly bound to the star. The orbits of the planets would also be more elliptical due to the weaker gravitational influence of the Y-type star. Earth would be a very different place under the dim glow of a Y-type star. The reduced sunlight would lead to a much colder climate. Earth's average temperature would plummet, oceans could freeze over, life as we know it would struggle to survive. Despite the dimness, Y-type stars emit powerful flares. These flares are sudden bursts of energy that can be harmful to life. They could strip away Earth's atmosphere and boil away any existing liquid water. The evolution of life around a Y-type star would face unique challenges. The habitable zone is close to the star, which means planets are tidally locked. One side of the planet always faces the star, while the other side faces away. This creates extreme temperature differences between the two sides. Life would need to adapt to these harsh conditions. Photosynthesis, as we know it, may not be possible. Life might evolve to use alternative energy sources. Y-type stars have much longer lifespans than stars like our sun. This seems counterintuitive, doesn't it? Smaller stars burn their fuel slower, which means they live longer. A Y-type star could shine for trillions of years, while our sun will only last for about 10 billion years. This extended lifespan could give life ample time to emerge and evolve. However, the slow evolution of a Y-type star could also pose challenges. Life would need to adapt to the gradually changing conditions over billions of years. While a Y-type star's habitable zone is close, life might find refuge elsewhere. Moons around gas giants beyond the frost line could harbor life. These moons could have internal heat sources, which could keep water in liquid form. These moons could be shielded from the star's flares. Life could thrive in these hidden oceans. The search for life beyond Earth should not be limited to Earth-like planets. We must consider all possibilities. The study of Y-type stars and their systems expands our cosmic perspective. It reminds us that our solar system is just one example. The universe is filled with a diverse range of stars and planets, each with its own unique properties. We are still in the early stages of exploring the cosmos. The search for life beyond Earth is a daunting task, but it is a journey driven by curiosity. By studying all types of stars, we gain a deeper understanding of our place in the universe. Y-type stars are incredibly faint. This makes them difficult to detect, but they are also the most common type of star in the Milky Way. They could hold clues to the early universe. Y-type stars were forming when the universe was young. Studying them could provide insights into the conditions of the early universe. They could also help us understand how the first stars and galaxies formed. If our sun were a Y-type star, life on Earth, as we know it, would not exist. Our sun's size and temperature are perfectly suited for life. We are fortunate to live in a solar system with a star like our sun. The study of hypothetical scenarios like a solar system with a Y-type star helps us appreciate the uniqueness of our own. It also fuels our curiosity about the vast and mysterious universe we live in. As we continue to explore, we may find that life is even more diverse and adaptable than we ever imagined.